All right. Systems of equations. We've talked about systems for weeks now, and we're kind of putting it all together here. There are about 3 methods for solving systems of equations. Actually, you can graph it also, but 3 algebraic methods. If the equations come to us like this, where it's slope-intercept form and x equals a number, all we're going to do is plug in number and solve it. So if I was just given a number, I would take that number, plug it in, and be good with it. If I'm given 2 equations that are both in slope-intercept form, I like to just set the 2 equations equal using the y as the joining part of it. So these guys, we're going to set equations equal. To each other. So what I'll have is mx plus b equals mx plus b. I'm just setting them equal. And the final one, if everything's in standard form, I use the elimination method. And that's the one where I get something to cancel out. I try to get either the b's to cancel out or the a's to cancel out. Excuse me, not a's or b's, the x's or y's. Excuse me. So get x or the y's to cancel. All right? So you've done all of these methods. Now it comes down to, can you look at a new problem and figure out what method you should use? Right, here's our first one. Oh, check this one out. You know, you can't tell it, but there's a negative on that right there. And this thing's a little bit out of focus. Good. Okay. Y equals 4. This guy's ready to go. I'm going to take that 4. I'm going to plug him in right there for the y. When I do that, I'm going to have negative 8x, negative 8 times 4. Negative 8 times 4 is negative 32 equals 8. I'm going to solve this 2-step equation. Negative 8x equals 40. X equals negative 5. Oh, and I went off the page, sorry. There it is. What does y equal? Y equals 4. What does x equal? Negative 5. Remember, that is a physical point where 2 lines are coming together. Okay, what's this one good for? Let's see, these are both in standard form. They're both in standard form. What do I want to do? Standard form. Let's see, where's standard form? Oh, use the elimination method. I'm going to use the elimination method to get the x's or the y's to cancel. Okay. I can do that. Man. Those y's, they're so close to canceling. They almost, if only one of those 10s was a positive. Let's make one of those a positive, right? Let's take this bottom one. We'll go through and switch all the signs on it. Now we're set. Let's see the problem. Negative x and negative 3x. That's negative 4x. My y's are going to cancel. Negative 20 is negative 40. So x equals 10. Now I need to take that guy and plug him right there. Negative x, negative 10 minus 10y, negative 20. Negative 10y equals, I'm going to take this guy, put him over there. That's going to take me to a negative 10. Y equals 1. 10, 1. Once again, this is a point where two lines are coming together. Let's see, I have a slope-intercept equation and another slope-intercept equation. What should I do on that one? Two slope-intercept. Set equations equal to each other. Okay. So negative x minus 6 equals 2x plus 3. Setting them equal to each other. Well, let's get something to cancel out. You know what we need to do? Let's add x. Let's take this guy right here, that negative x, drop him on top of this guy as a positive x. So I have negative 6 equals 3x plus 3. And we'll take this guy, drop him over here as a negative 3. Negative 9 equals 3x. X equals negative 3. X equals negative 3. Now let's take this negative 3 and let's put him right there. You like the sound effects? Shh. What's that going to give me? Have some space here. So y equals negative x, negative 3, right? Negative x, but x is negative 3, so negative 3, that's 3 minus 6. Y equals negative 3 also. Ah, look at that. Negative 3, does that work? Negative 3, that works. Good stuff. All right, that's it. Thank you for watching. We'll be working on this in class. So if you're not getting it with the video, ask me, talk to me, but we'll go over it in class and make sure you get this. Thank you. Bye-bye.